going to work on the last bit of 6-7 today. Tomorrow gets us into graphing. And then Friday, we're going to start doing some of the little writing equations given ordered pairs, as well as some of the word problems thrown in. Now, then on Monday, what we're going to do is we're going to review everything we've done for the first half hour. Last 15 minutes on Monday, I'm going to give you the non-calculator part of this test. Therefore, Tuesday, we're going to do the regular part. Okay? Yes, sir?
Can we do it the first 15 minutes so we don't run out of time?
No.
Okay.
Because I don't want to do that to you after a weekend. I want to at least give you some time to come back to remember what you were doing.
Okay.
Okay? I hate trying to do any type of assessment on a Monday, but the fact that I can throw it in there after reviewing some stuff, it's okay.
Okay.
All right? Yes, ma'am?
If we're not going to be here on Tuesday.
We'll have to do it on Wednesday. All right? So that's kind of what I'm looking at being able to do. I don't think it's going to be that bad, to tell you the truth. The stuff that we've been working on, you guys have all been, it's kind of the same thing over and over and over again. You know, there's really not a lot of variance thrown in here. So when it comes down to the non-calculator part, it'll probably be solving for zeros with some funky numbers that you have to synthetically divide and know how to add and subtract. Shouldn't be that bad. What we're working on today is we're going to be working backwards. We're going to work backwards. I'm going to give you zeros. You tell me the function. There's a little bit of imaginary stink today, yes. So if I give you zeros, if I give you the following zeros, 2, -3, and 5. If I give you those 3 following zeros, what's the degree of your polynomial? It's a third degree polynomial. If you have those 3 being your zeros, what are your 3 terms? So do you see the idea of why I kept saying over and over, if you have a 0, what's your term? Or if your term, what's your 0? Where that all came into play? I was actually setting you up to do this rather easily. I don't know. I don't know. So your function then, your polynomial function then would just be to multiply all that out. Pleasantly surprised. X squared plus x minus 6 times x minus 5 gets you your function. What's so funny? Huh? When I don't understand what I'm talking about. It's like I am a robot. So you combine like terms. This should be relatively easy for you guys.
Wait, there's confusing. Why does the paragraph the parentheses have an end but not a beginning?
The what?
The one, the second from the bottom. The parentheses has a left.
Oh, sorry, I didn't mean to put it there. I didn't mean to put it there. That's all. So what's happening here, guys? See, I'm giving you the zeros of the polynomial function to start with. You're just working backwards and building the function. This should not be very difficult because of the fact that you know the difference between a 0 and a term, and that's what we've been working on. We've been working to find zeros, and every time we found a 0, what did we write down? We wrote down the term. We've been working our way into this for a while. Okay. Now, is it always going to be this fancy and this easy? No. Oh, God, no. Because you're going to get this.
2, 3, 5, and 7. No. I thought it was going to be 7.
Now, what I want you guys to see here is that, once again, how many zeros do we have? 3. So what's the degree of the polynomial? 4. It's going to be the third degree. Now remember what this means, guys. Nothing means a 1. Nothing is 1 here. Where? All right, so let's just be quiet and write something down there, okay? Come on. Remember when we have zeros. If you have zeros, what I want you to You'll get better at it, trust me. When we've always talked about zeros, we've immediately gone into terms. Okay? We have it as x minus 2, x minus I, and x plus I. You agree? This is what we've normally done. One of the things that I'm kind of doing the longhand version of this to start with is that if I look at the x minus I, x plus I, doesn't that set up as a difference of squares? So isn't this, in essence, x squared minus I squared? And what's I squared?
-1.
What's minus -1 equal to then?
Positive.
So this develops x squared plus 1 as a term. Think about how you solve for x. How do you find zeros? If your term is x squared plus 1, and you're going to find the 0, you set it equal to 0, and you get x squared is -1, so x is plus or minus I. That's where I got that. Looks like he's kind of happy. It's his ears.
Looks like he's crying. Let's name him Ike. Let's name him Ike. He's got eyes.
Now,
Wow.
No.
Yes.
what you wind up with then is x minus 2, x squared plus 1, and you just have to FOIL that out. You're still going to get a third degree polynomial. X squared plus x, and there's your function. Okay? It builds it out that way. It's the same basic principle, but the weirdness throws in when you have the imaginary. Okay? Yes, ma'am.
So that's that.
Yeah, that's what the function would look like that has those 3 zeros. Okay? You're just going backwards. So if you wanted to factor all that out, you can do it, but it's just kind of a pain. You're going to wind up with, you can see how you get a GCF, you get an x squared, you only have a 1. So you have x squared plus 1, and an x minus 2. And that's where you get your zeros. Now, what will happen sometimes with the book is that they'll do this. They'll give you those as your 2 zeros. But if you have a negative I, what else should you always have? You're always going to have positive I. Remember, the I value only can be derived if you have a squared term somewhere. So if they give you the positive I, there has to be a negative I. If they give you a negative I, there has to be a positive I. That's kind of the one twist that they throw in here. I don't know why they do that. They just do to annoy you, and it usually works. Yeah. So in this case, this should be very fast then. Knowing that your zeros are plus or minus I, what's your term?
X squared plus 1.
So you have x minus 3, x squared plus 1. You just do it that way. Okay? Now, that's not all of it, because sometimes i's have coefficients, don't they?
Yeah.
They do. For example, what happens if you have zeros of, I'm just trying to make numbers real easy just for argument's sake. If I have 2, -3, and 2i, what else should there be? There should also be a -2i. Okay? Book sometimes leaves it out. Got to remember that there's one of them, the other has to be there. So when you get to that part, you know what your first 2 zeros are. So your terms would be what? X minus 2, x plus 3?
Yep.
Okay.
Yeah.
What do you get there?
X squared plus 4.
Very good. Everybody see how you're going to wind up with x squared plus 4? You could FOIL that out if you'd like. You'd get the same result. Just if you start to recognize how do you get the I value, and you just FOIL, I don't want to keep saying FOIL, but you just keep distributing it out, and that's how you get your solution then. Yeah. Now, it having 4 zeros, this should be what term then? What degree? Fourth degree. Do I need to show all my work on this one at this point, or you guys can find multiply it out right now?
Yeah, it just takes time.
It doesn't take that long.
Yes, it does. It's a pain to do this because, like, it hurts.
The ambulance.
Yeah, go ahead, call the ambulance.
I have the ambulance on here. I gotta find it.
Really? Don't play it because it makes me cry. Oh my God, where am I going?
So let me annoy you completely and fully. Sorry guys, let me go back real quick. Go ahead, Mom.
Wait, so when you were saying, what did you say about the fourth?
See how there's 4 zeros?
Yeah,
So it has to be a 4th degree polynomial.
so like another,
X to the 4th. Your answer would be something to the 4th.
okay, so that should not be it.
No, you have to, you still have to multiply all of it out. I just stopped.
Oh,
I was getting bored.
okay, how do you go here?
Do you want? I'll get bored, thanks. 1 second. If I FOIL this out, I get x squared plus x minus 6 times the x squared plus 4. Oh, crap, what's that?
How do you multiply that minus 3 and minus 2? Like, do you not FOIL?
You're not FOILing, you're just distributing. Distribute the x squared across all of them. Send it out, you get x to the 4th, x cubed minus 6x squared. Do that with the 4. All you're doing is distributing property twice. After you do that, it's just combining like terms. Okay? Yes, ma'am.
How did you get x squared?
What happens here is you get x minus 2i it's a difference of squares. X squared minus 4i squared. I squared is negative 1. X squared plus 4. Okay. When you combine all that out, please stop popping your gum. Driving me nuts. And that's your So what happens in the very end, what I meant by saying you get a 4th degree polynomial, you'll have something to the 4th power in there. And you just combine your like terms into a nice descending order and you call it a day. Okay? Does that make sense then? Now, like I was saying, the weirdness comes in when you wind up with 3 minus an I, 3 plus an I. And this is where it gets very tricky. Remember what each of these means. These guys are zeros, okay? So when you have zeros, your term is generally going to wind up looking like, well, x minus 2. That one's okay, right? My next one, I'm going to put it'll be x minus 3 minus I. I'm following the same pattern I've done all along. The other one would be x minus 3 plus I. Think about what we've always done. You've taken your value, it's x minus that. It's x minus that. It's x minus that. Okay? Distribute the negative. Very good. At this point, what you want to do is exactly what Clay said. You want to distribute your negative. When you distribute your negative, in here you get x minus 3 plus I. You okay with that?
No.
Distributing out the negative, you get negative 1 times 3, negative 1 times negative is positive.
Oh, okay.
I do it again over here, you get x minus 3 minus I. Up front, I still have that x minus 2. We'll worry about him later.
Wait, after we got rid of the inside parentheses, why do we still use the?
I'm just leaving them up for right now, okay?
Okay.
Because of the next step. If you guys turn around and look on the backboard, look, I'm using it.
Whoa. I still have been there all day. 'Cause I've been here for 2
There's
weeks.
reasons that I do it.
Run.
I'm fast.
He's the flat. I thought she was. What'd she say?
I ran back there. I ran so far away.
I thought you were.
Okay. What property is going on back there?
Transsyllogism.
Transsyllogism is not a word. Stop talking to me. What property is going on back there?
You get that joke, right? You get it.
Associative. Associative property tells you you can group things in different orders. And the order in which you group things really doesn't matter. You're still going to get the same answer, right? So if I look at this, Can I do that?
Yeah.
Okay.
Okay.
This is where I'm going to make you guys really pissed off at me. More so than normal. And it's okay. I'm going to show you a trick as to why this process that we're about to do always works. It's going to be the same process each time. Remember, you guys are good at replicating processes. That's why you got here. I'm going to,
I don't think it's processes.
whatever. I'm going to make sure you guys figure out what's going on. I'm going to use something called U substitution. This trick is called U substitution. What this allows you to do is to take something that looks really crappy and turn it into something that looks a little bit easier. You use this a lot more. Well, you will see it again, probably not so much in here, but in pre-calc and especially in calculus. They do this all the time. It's a very simplistic way to make complex things look easy. Because now, if I let u equal x minus 3, don't I get u plus I, u minus I?
Aren't we back when we started with the 3 plus I, then we get
Do I
big
know?
again, and then
Yes, you do.
do we make mega U?
No, hold on. Look at this. That was good. That was very good. Now, look at what you have.
Yeah, but what you got.
Look at what I have.
What does you have?
Is it June? All right, look at what we have now. Okay. Just snort.
Yeah, you and I. That's good.
Isn't that a difference of squares?
Yes.
U squared minus 1.
What's I squared? What is some minus negative 1 equal to? What was u equal to?
X minus 3. Look at that.
Which is, no, that's not. Because that's just x minus 0.
What happens here is we're taking something that looks kind of weird with these extra terms in here. Instead of foiling it out there, which we could have, did a little shortcut and had u squared minus I squared. That's u squared plus 1. U squared is x minus 3. When you simplify that, you get x squared minus 6x plus 9 plus 1, which is x squared minus 6x plus 10. What happened here is that instead of foiling all of this out, which you could, you get x minus 3 quantity squared minus I x minus 3 plus I x minus 3 minus I squared. Isn't that the same thing here? The trick here is that this simple substitution method will allow you to shortcut these types of problems. It's x minus 3, when you distribute it out, you get x squared minus 3x minus 3. And then you have the last big, yeah, don't kill puppies. What was that? What do you back up here? And then you had x minus 2. And then you have to distribute that out. Okay. Now, again, I'm going to walk you through another one that looks just like that. The process is identical. You should pick up on how fast this becomes because it doesn't change. Yeah.
So you equal anything that.
I know.
Not what I meant.
What's happening is, the way I wanted to show you guys was instead of going through the process of foiling all of that out and making it look really weird, by breaking it into something that's really quick, knowing that you wind up with a difference of squares, you should have recognized the pattern and gone. Yes, sir?
I just want to say this because I just came up with it. Anything you can do, I can do better.
I'm out of here. I'm out. Good night, everybody.
5 minutes to go over, so don't judge me now.
Put it on the window.
Make sure it's not negative I.
Oh, dang it, Colton, I'm going to cut it.
Put it on a window. That's good.
No, can I wait to the end of class? I still have to take notes because I ran on.
Now, let's say you had this. Let's say you had those two given to you. What are you missing then?
Negative 3i and 4 plus I.
Good. You're missing a negative 3i and a 4 plus I. Those things will always be parts of it, okay? So you'd have to put those in. Okay? The plus or minus 3i, you should be able to come up with that in your head. What's the term? Good. You have x squared plus 9. The other one, remember what we just did. We had the 4 and the I. Wasn't it just wasn't it that? Always going to be that.
No, there was no square, was there?
It's the quantity x minus 4 when you're moving them around. It's always going to wind up being like that. It's a nice pattern. Look back where we did. When you distribute it in, you had x minus the junk, redistribute, you wind up with x minus 3 plus 1. That's always going to work if it's 3 plus I, 3 minus I, 6 plus I, 6 minus I, or anything like that. It's the same process. The trick is, you shouldn't have to. The trick is then, it's just knowing that you're not killing puppies. What's that? I don't think we're going to get that complex. Good. I mean, 4 minus 2i is the same thing as 2 minus I, isn't it?
Are we allowed to show that bracket stuff we did earlier? It's like,
If you want.
that helps a lot.
Oh, sorry, that was plus 16. So your function then, your function winds up being something like that. It's just a matter of distributing out and combining like terms. Okay? It's a nice little trick to set those things up. I don't think you have to worry about, 7 plus 3i or anything like that. I don't think we get that's good. That's just. I don't know how you. I mean, you'd have to almost distribute all that out to make it work. I don't think the substitution trick would work. I mean, it's not like you couldn't do it. And then, like I said, now it's just a matter of distributing and combining like terms. So that shouldn't be that bad. So it's your f of x, x to the 4th, 8x cubed. 17x squared, 9x squared, minus 72x plus 17. What is it? Thank you.
Oh, we didn't need you for this one.
And then this one just becomes 26x squared. All right. What's up? Yeah. Make sure you distribute everything out. You don't want to have any parentheses in there. Yes, sir.
Why didn't we need you for this one?
It's the same thing every time. You can use you if you like. Okay. What I want you guys to do tonight is still the section 6.7. It's page 370. I want you to build those functions. Okay. It's a mixture of some of them are regular, or some of them are just plain old boring integers, some of them are imaginary, some of them have the imaginary pluses and minuses. Just a matter to go through. Okay, shouldn't be that bad. Tomorrow we'll take it and go from given zeros to writing the equations. We'll build some equations, or no, we're doing that tomorrow, we're doing graphing. We're graphing tomorrow. So we're going to graph tomorrow. Make sure you have your graphing calculators. We're going to talk about localized maximums and minimums and what they all mean. Yes, sir.
I promise you, I will actually do the homework tomorrow. I will do it. I have to because I have paper in this thing, so that forces me to actually bring my math book and stuff like that.
I'll gladly pay you Tuesday for a hamburger today is what I'm hearing.
You will pay for what I